Welcome to Mechanical Tutorial. I am going to teach you different techniques in SolidWorks for mechanical engineers. I am going to train you different modules like surface modeling, sheet metal and enclosure design, product design, plastic components design, reverse engineering and many more tips and tricks in SolidWorks. Hi, today I am going to explain about this sheet metal component as well as drawing. So I'm going to show you how to create this drawing for this component in folded state as well as in flat pattern, and I'm going to upload this file. You can check the link in the description. See, this is the component. And this is the drawing. So this is in folded state and this is in flat pattern. So let's start now. So I've taken new SolidWorks part file. Select the top plane, go to sketch, select center rectangle, so this is a 90, this is 143. So go to sheet metal tab and select the base flange. So this is 2 mm and I have taken K factor as 0.45. Should be always less than 0.5 for any sheet metal component. So say OK. Now I am going to create this edge flange. Select this edge flange and select this edge and say OK. Now go to the sketch and edit sketch. So select this point and move little bit left side. So it is unconstrained. So the distance between this line and the outer edge, it is 49, and this outer edge to this top line is 132. See here, it is going to create in this manner. Come out of this sketch. See, there is a tearing operation here. So to avoid such problem, we have to edit this edge flange and select the third option, that is bend outside. See, it has come outside. So we have to use this option. Say OK. Now select the unfold and select this top face, collect all bends and say OK. Keep it normal. So I am going to create these cutouts. So go to extruded cut, select this face, draw center point arc. So select this point and select this edge and this edge, and take two lines, join this point, that is vertex, and this end point. Once again draw this line joining this vertex and this point. See,
we have to make sure that these 2 points are joined, move together. So this radius is 27.5, so it is fully constrained. Now so I'm going to create this bottom cutout. Select corner rectangle, simply draw in this manner, and select the fillet and select this point. So this is around 25. And the distance is 42. So it is fully constrained now. So come out of the sketch. So here we have to link to thickness. It is always mandatory in sheet metal, and normal to cutout, and say OK. So this cutout is done. Now I am going to create the other cutout. Select this face, select extruded cut, select corner rectangle, and select the fillet. So fillet is 25, say OK. Come out of the fillet. Now this value is 50. And the distance between this line and this edge is 50. Now draw one corner rectangle at this location. So dimension is the distance between this line and this edge is 10. And this value is 10. And this is 37. And this is 30. So now it is fully constrained. Now we have to apply the fillet. Select this. So reduce the value, it is 25. So just this radius is 5, and now select this all the vertices, corner points, say OK. Now it has been created. Come out of this sketch. So link to thickness, select normal, see here. Now cutouts have been created. Now we can fold this component. So select the fold command, collect all bends, say OK. See here. Now I am going to create these embossed features. So go to design library, in forming tools, select embosses and select countersink. So before that we have to create one sketch. So select this top face, select this sketch. So we have to draw the locations of these embosses. So draw 3 points select this point, and this point, make it vertical. Now dimension this. So this is 42, and this is 25. And distance between this point and the edge is 25. So come out of the sketch. The sketch has been created now. So it's easy for us to place this emboss feature. So select embosses, countersink, and place it here. And simply go to the position tab, right click and select it, just so that we don't have to draw any points. So simply drop it here. Now we can select this point and this point. So come out of this. So we have to see the orientation, whether it is in bottom side or not. See here. Say OK. Otherwise we have to flip the tool. Say OK. So it is created now. Now we can hide this sketch. If you have instances in sheet metal, so better to draw the sketch and place the forming tool. That is best practice, so that we don't have to create this sketch in the position tab. Sometimes it goes to the 3D, so it creates a problem for us. So the component is ready, so we have to apply fillets. So go to corners, select break corner. So here we have to select this option, fillet. So this is 5 mm. So select all the sharp corners, 1, 2, 3, 4, 5, 6, 7, 8. Say OK. See here. So this component is ready. Next I am going to show you how to create this drawing. I have taken a new drawing file. So I am going to insert this component. So initially I am going to place front view, and here scale is important. So it has taken 1:2. So here we have to check the properties. See here, the scale is 1:2. So we have to set in the sheet itself so that it reflects on in all the views. So that is very much important. So if you want to modify the scale, we can modify here. So this is front view. Now I am going to place right side view and top view. So these three views are important. Now we can place one isometric view, selecting this front view, and simply can place like this and drag and move here. So you can keep it in shaded form. So now I am going to dimension. So go to annotations, select the smart dimension. So this is the height. This is 132. this is 94. So the distance between these two edges is 143. So this is the overall dimension of this component. So next I am going to show you this cutout dimensions. So this is 30 distance between this edge and this edge. So select this edge and this edge. So this is 10. This is 10. So while placing the radius should be careful. See here. So simply place it here. Click on this point. So this is R25. This is 50. This is 44. See the other side, top view. So this is 44. So select this circle. It's 25. See, after placing the dimension, we have to place the center marks. This is very much important. Don't place the center marks, because when we place the center marks and give the dimension, sometimes it goes to the dangling. So to avoid such problems, we have to select this edge. So this dimension is taking the reference of this feature, not the center mark. So later we can select these circles for placing the center marks. This is very much important. So after placing center marks also, we have to select the edges, not the center marks. See, this is 42. So zoom here and place radius. Simply place it here and flip it. So radius we can keep to 1 decimal. Or we can remove the decimal value. So as per the manufacturing requirement. So this is R5. Here we have to type typical. Similarly, for this cutout radius, since we have 4, we can place this radius and type 4x and give this space. So here this radius is having all the sides in different flanges. See here. So we cannot show in one view. So that's why we are typing as typical. Here in single view we can show the radius. So all the 4. So we are typing 4x. So depending on the requirement, we have to show typical or define x value. So go to the drawing, select broken section view, draw one line, and here depth we can select this edge and say OK. So it has created broken section view. Now select the detail view. So draw one circle from the center. See, it is creating one broken section view, and this is detail D. So select this edge and this edge. So we have to select the edges, this edge and this edge, and go to sketch and select this point. So point is created here. Similarly, select this edge and this edge, select this point. So give the dimension now. Select this edge and this edge. This is 5.7. And we can show this radius. So we can go to edit text and we can type 3 places. Save. So this is the drawing in folded state. Next I am going to show you how to create this flat pattern drawing. So this is brief about how to create this component in sheet metal module in SolidWorks. So we have learned how to create this component, drawing in folded state as well as in flat pattern. So I'm going to upload this drawing file, so you can check the description for the link. Thanks for watching.